So here is, I should say here are the answers to last night's homework. Any questions so far? We're doing okay? All right. Now, for this one, I made up the graph. I didn't put it on last night's homework, so let's do it together now. Ready? Describe a situation that graph might model. Go ahead. Somebody come up with a situation that graph might model. Let's go, Mr. Dessing.
Someone's climbing up a ladder, and then they fall off the ladder, and then there's a slide upside down, and they hit the slide like a ramp, and then they hit a wall, so they stop.
I don't think so.
I think it's because there's negative elevation.
That's right. That's exactly why. Because if you go down the slide, unless you specify that the slide goes below ground level, then we have a problem. Because where does slide stop? At ground level. And the horizontal dark black line would be ground level.
Okay.
So we need to be more specific. Spencer.
Okay, a bunch of penguins, right?
Yeah.
They're going up the hill.
Good.
They get to the top.
Good.
They look down.
Yep.
Now, one of the penguins is really mean.
What's
and
his
he
name?
doesn't want Frederick.
Okay.
Okay, so Frederick, the mean penguin,
Yes.
takes all of his penguin friends and throws them to the bottom of the hole, right?
Okay.
Okay. And then like they hit it so hard that they crack a hole in the ice and go to the water underneath, and they create almost like a ramp, right? Then Frederick takes one of them, lays them down, and then rides him like a surfboard all the way down to
Good.
the bottom, and then rides up the ramp.
Why did he go up the ramp? Well, when
Because
he
the
goes
skate-
through the hole in the ice, he had to go below the water level, right?
Yeah, and then there was a ramp.
There's a ramp on it. He didn't just
There was
swim.
a ramp of penguin bodies.
A ramp of penguin. Okay. Why was he motivated to go up the ramp of penguin bodies? What I'm wondering was there a leopard seal that was trying to eat him?
No.
No?
Frederick's just king penguin, and sometimes he abuses his power.
Okay. All right. So he's kind of like Obama.
The dangers of monarchy. Dangers of monarchy.
See, if I said that with poor Noah in class, I think I'd hurt his feelings. But
Yeah.
yeah.
It's a good thing he's not here right now.
No. But we like Noah. Noah's a great kid. He's just misguided in certain areas. Okay. Now, what interval has the, what does it say, greatest rate of change? Looking at the graph, what interval has the greatest rate of change? X equals what to what? Alejandro?
3 to 4.
3 to 4, good. This is when the slope is the greatest. That's the greatest rate of change. So 3 to 4. What about the least rate of change? Spencer?
4 to 6.
Yeah, definitely 4 to 6. Well, is that 4? No.
No,
4 to 6 is 0. This is negative, so that's an even greater rate of change. I mean, actually a less rate of change. Sorry about that. Express your answers in bracket notation. We would just use the brackets because everything is solid pointed. All right. Is there an interval over which there is no change? Yeah, there are actually 2 of them. What are those intervals? Somebody other than Alejandro or Spencer? Come on, let's go. I know it's a Wednesday morning, hump day, but we have to find a way to get through this. Go ahead.
4 to 6.
Yep.
And wait, I'm still counting the boxes.
This guy to this guy?
Yeah, that.
Good. Well done, Lipstick.
Thank you.
Okay. Next up, here we go. Domain means
X.
X.
Input.
set of all inputs, X value, range means,
Set of all outputs.
and it is the?
Y.
Nice. Okay. Are we good?
Yeah.
All right, so you helped each other on your quizzes. If there are any lingering questions on quizzes, you could ask me at lunch, or you could ask me tomorrow morning, and we will go over it then. Now, let's talk one more time about one of these piecewise linear graphs. Okay. So did you see how the second quiz helps the first quiz?
Yes.
Right? How many people did better today?
Yes.
I think every kid in the class did, right? And then tomorrow, there's just these lingering little bits of mistakes to correct, and already we have tons of kids with 90 and higher. So by the end of tomorrow's quiz, it should be virtually the whole class with 90 or higher, and a very good chance at a good number of hundreds. I think right now we probably have about 200 or 300s in the class with probably about another 5 or 6 95s. Hopefully by tomorrow, we change that into about 15 or 20 90s and 95s and 2 or 3 grades that are almost that. All right, so interesting question on B here. Okay, a couple of people brought it up and asked it when we were here, and I kind of chose not to answer it because I wanted to answer it to everybody, not just one particular person. -3, -1, rate of change at 3, starting at the point -3, -5. So, the first thing that I need to do, oh, here we go again. I have a tech request in for stopping me from looking like a monkey. Ooh, 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 ooh. I feel like a chimpanzee looking at like a video game for the first time.
Well, if you're a chimpanzee, then where are your bananas?
I actually didn't bring bananas today, I brought grapes. All right. You know, I'll tell you what was pretty cool. When we got Ziva as a puppy, she was 10 weeks old to the day. And a couple of days after we got her, we were watching like, I don't really watch a lot of regular TV. If I watch TV, I like to watch like nature shows or documentaries or something like that. So, Mr. Rowland, can you open that window, please? So we're watching this documentary on chimpanzees, and it's talking about how chimpanzees are the only species other than man that declares war. And they will literally get a clan of chimpanzees together and attack another clan of chimpanzees. And they will start this, literally a war. They pick up tools in the form of sticks and they attack them. So Ziva's laying in the living room. She's like 10 weeks and a few days old. And she's laying in the living room and she's watching the chimpanzees on TV. Now, the way our house works is you have the TV, and then behind the TV is a wall, and then behind that wall are stairs that goes up to the second floor, or that go up to the second floor. So Ziva's watching the TV and she's like, and every time the chimpanzee is like, ooh, 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 ah, 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 ah. And it's like an aggressive sound because they're about to fight war. You can see her leaning into the TV. And then the chimpanzees run into the screen, which makes them going into like the back of the TV, and she runs up the stairs and tries to catch them. So it's very cool. She's a very protective dog. Okay, so we start at the point -3, -5. -3, 1, 2, 3, 4, 5. There it is. Yeah. Okay, so now, up until the interval where x is -1, I want to rate a change of 3, and I want to use an open circle because of the parenthesis right there. So, up 3 over 1,
3 over 1 again.
and then up 3 over 1 again, and there's my open circle.
So you do that until your x is -1.
Right, which is exactly what I did. Now, now I'm going to jump. It's not what you call a continuous graph. A continuous graph, you never take your pen off the paper. A discontinuous graph has a point where you have to pick your pen up off the paper and put it someplace else. So now I'm going to jump to the point 0, 0. Now I know it seems kind of weird because this says from -1 to 3, but 0, 0 is within that interval, so I can make the jump horizontally rather than vertically. We're used to vertical jumps. And now the rate of change is -1/2. So that means down 1 over 2. And it wants me to go up until 3, so it's down 1 over 2, which puts me in the middle.
That means you're starting at -1.5.
Exactly, for the y value. Now, from 3 to 6, starting where I left off, the rate of change is 1, and it was already a solid dot, so it doesn't matter. So rate of change of 1, up 1 over 1, up 1 over 1, up 1 over 1. So this goes like this goes like this.
What
Did you see how it was dragging behind there? That's why that happened. This should not be here, so get rid of that. In fact, let me be nice and crystal clear about this. Yep, good. Okay, and the last part says, starting where you left off, rate of change is 0, out to 8. And then we'll do my rate of change to 8. Okay? So again, piecewise linear graph, this is probably like the 5th one that we did. This particular problem emphasizes the fact that you can jump horizontally, you can jump vertically. In other problems we did that. And it also emphasizes the idea of open-closed circles and so on and so forth. So I think we're getting along much better. I told you the quiz grades were significantly improved, and I think we're very, very close to mastering this particular skill. Any questions? Okay. Sydney, how are we looking with this? Nice. Somebody other than Sydney, I think, talked for her, or she's got serious ventriloquial skills. Okay. A ventriloquist, like, makes you think you're making noise from one area, but it's coming from the other. All right, time to do a little experiment. Let's drop something while we're standing on the teacher's desk. So, who wants to stand on a desk? Lipstick, come on up.
There's two
Yay!
Sydneys though. I don't know which one you're talking to.
Okay,
I don't know Tanya.
You
All
just
right.
say Sydney 1 or 2.
Sydney sub 1, Sydney sub 2, you're Sydney sub 1, you're Sydney sub 2.
Okay.
Stand up.
The second version
Yeah,
is
it's
good.
cool.
All right, lipstick, here it is. Hold it up high over your head. Now, I want you
Don't
to
jump down
see
the
what you
slope.
notice here when she drops this. Go ahead. Notice things again, particularly compare the relative speed the instant she drops the ball versus the instant the ball hits the ground. What do you notice? Up and down.
Straight up.
What's that?
High five.
What do you notice, everybody?
Go straight up.
Well, it's actually, well, the bounce goes kind of straight up. Yeah, but talk to me about relative speeds.
It slows down once you drop it.
When you drop it, it's
It's
going really
fast.
slow. In fact, right now it's going 0. When I first drop it, it goes pretty slow. But as it gets close to the ground, it's moving much
Quicker.
faster. Yes, much quicker. Okay, so that is the motion, or the effects of motion, and it's also the effects of gravity. Do you know, no matter how much you might think you hate me this year, we're attracted to each other? Did you know that?
No.
Gravity does not only apply to Earth. Gravity applies to your little sisters. It applies to your parents. Heck, it even applies to Hillary Clinton.
Oh my God.
Gravity is the force of attraction between any two objects in the universe. And it's true, it's any two objects. It could be me and you, it could be me and you, or it could be me and the microwave.
Microwave.
Now,
I'm connected
the
to
thing is, if you calculate the formula for gravity, it's this F equals G, which is the universal force of gravitation, times M1 and M2 divided by the distance between you squared. And the bottom line is, the further the distance between you, the less the force of gravity. And the larger the mass of the objects, the stronger the force of gravity. So for instance, if we jump on Earth, and I am living proof that white men can't jump, okay? Don't get wise, you. Now, if I jump, the force of, see, the world loves me so much. The world does. It loves me so much. It just won't let me jump very high off of it because it wants to keep me next to it. It does. It really does. But the moon doesn't love me so much. See, the mass of the moon is about 1/6 the mass of the Earth. So the force of gravity on the moon is much smaller. Now, did you ever see the films of the astronauts walking on the moon? And they're
Yeah.
like, and when they jump, when they walk, they kind of come higher off of the moon. And did you see how like they have extra thick, heavy plates in their shoes to keep them? Otherwise, they could like get up and fly away. Okay. So those are examples of the force of gravity. And if you're playing baseball, drop your bat, and you hit a long fly ball deep, way back, you hit it. Your bat gives it force away from the Earth, but gravity pulls it back toward the Earth. Now, if you're a lacrosse player, or if you're a baseball player, or if you're a basketball player, you actually have this built-in ability. Like if you're playing basketball, you say to yourself, how far and at what angle do I have to release this ball so that the force of gravity actually pulls it into that hole? All right? That's something that you actually process in your mind. But there's a lot of mathematics to it, and it actually forms a shape that we call parabolas. Okay, so, rid of that. Here we go here. I'm going to skip the videos because I don't have a lot of time. Now, when I do this parabolic shape, and this applies to a basketball being shot, it applies to a baseball being hit, it applies to a ball being thrown, it applies to all of those things. It's all going to be done with this general parent formula, if you will. H of t, H stands for height. H of t means the height at any particular point in time. So the height at any point in time is at squared plus bt plus c. So the question you have to ask yourself is, what is a, what is b, and what is C. Now the cool thing is that A is always the same thing. It's either negative 16 or negative 9.8. This is the gravitational constant. In other words, it is gravitational, I left out the TA, constant. This is the force that brings the ball back to Earth. B is the upward velocity. I believe this is all spelled out for you in your papers. And C is the height you start from. Now, is it pretty obvious that when Lipstick went up there and dropped the ball, and she stood and put the ball up really high, that things were a little bit different than if she would have went and dropped the ball from 3 inches above the ground? Right? Could you see that the ball would travel differently? Okay. So, what we want to do is we want to be able to write equations that are based on this. Now, the first thing that we have to be able to do is evaluate functions. I think we did enough of that yesterday. Let's put it all together. Here's the answer. If the bell rings, just follow this through because it's pretty easy. Ready? H of t equals, it's going to be, this is the English system, so it's negative 16t squared. The negative 9.8 is for metric system. So the English system, anytime they say English, it's always going to be negative 16t squared. Then it says it has an upward velocity of 25 feet per second. So it's plus 25t. And then it says a height of 10 feet, so plus 10. And that's the answer. Always negative 16. This is the upward velocity. This is the height. Let's try another one. H, don't move, don't move. H of t equals negative 16t squared. Then it says what? What's the upward velocity? 20, so it would be plus 20t. And what height did you start from? What height did you start from, guys? 6. So plus 6. So always negative 16, upward velocity, height you started from. Never changes, all the way the same, every single problem we do all year long. Hasta la vista, vaya con Dios, ta-ta. Arrivederci, smile a lot. Ciao, arrivederci, adios amigos, amigas, cheerio, yes. Yeah, I'll do it again tomorrow when we go home. That's my own. You should smile a lot. That one question we'll cover in class. The rest of it you should do. Yes.
How you're always looking for new ways to say goodbye.
Yes.
You should say it in sign language. I don't know what it is.
All right, you figure it out, and I'll do it.